This is a follow-up to my last video, code from my nephew. So this is more code from my nephew. Um, it's pretty cool. It shows a nice little function here. Has asks a question. I actually haven't had a chance to show this to my daughters yet, but they'll think it's pretty awesome. They'll be very excited. Changes this into an integer, and then matches to my kids. Otherwise figures that it must be me or my wife. So there were some of the stuff we talked about last time applies as well. Like maybe using argparse. At next birthday. Parser dot. Oops, sorry. We should actually have description equals. Okay. Handle the type there. Help equals age. You are going to the next birthday. Args equals parser dot parse args. We could try to handle if args dot age is less than 1, parser dot error. Not a valid age. So I think this covers pretty much everything we covered in the last video. We checked for a boundary condition. Let's see. So, but there's one other. Oh, we of course need import argparse. There's one other way we could add some clarity to this, I think, and make it easier to add other data later. So, and that is like this. Name to age equals, this is going to be a dictionary, and so this is going to map from a string. Oh, actually, you know what, let's make this age to name. No, let's make it name to age. That's more correct. Okay. And we'll just assume everybody else is a parent. Now we can do something like, let's see, if args.age in name to age.keys print hello. What is the best way to do this? Well, here we can do something like this. Age to name equals equals vk for kv in name to age dot items. So all right. So what's happening here? Here we have a map of a name to an age. In this case, we're going to take the items. So what named age dot items does is it'll print or it'll return a list, I think, yeah, list of tuples, and each tuple will look something like this. So we can take that, and for each key, which would be like althea, and value, which would be like 8, we flip them, and we make the value the key and the key the value. So that's why this one is now, instead of name to age, it's now age to name. So now what we can do is get the name that way. Age to name dot, not dot, args dot age. So in age to name, there will be a, we can actually just do, oops, age to name, oh yeah, the cake is a lie, yeah, dot keys. Okay, so if it's in the keys, which will be ages, then get the value, which will be a name. And so now we don't have to have this. If we added, you know, if we had another kid, which we're not planning on, other kid, that's a great name. Then we don't have to actually change the code now because it can handle any changes in the data here. So that's pretty cool. And we still have this assumption that if you're not in there, then okay, then you must be one of the parents. So now let's see. Will this actually run? No. What did we do wrong? Oh right, missed a paren. Okay. All right, there we go. And 6, and if we say 5, okay, that's a little silly, but yeah. All right. Now it's assuming that we're telling the truth. Okay. So here we basically use data structures as a way to record the data instead of recording the data as code, and that means that we can have a little less code that is reused in multiple cases. All right, there's another problem here. What if we, let's imagine that Genoa had a twin sister named Pinky, and now what happens if we tell it 6? This is interesting. It says hello Genoa, and it just doesn't know about Pinky. And in fact, if we were to do something like print age to name, I'm fairly confident it will just have the 2 entries, Althea and Genoa. So Pinky just got left out there, and whether it was Pinky or Genoa that got included or left out is entirely like arcana of how the Python interpreter works and how hashes work, and it was kind of a coin toss. So I would not have been able to predict ahead of time which one got left in. So anyway, all right, that's kind of not what we want. So we can do something like this. Age to names equals is a dictionary for name age in name to age dot items. If age in age to names dot keys. Or actually, let's say if not, then age to names age is a list. We do this because the dictionary right now doesn't have anything in it. So the first time we run into 8, we need to say age to names 8 is a list. And then the first time we run into 6, we say age to names 6 is a list. And the second time we run into 6, we need to not make it an empty list again. And then age to names age dot append name. So now we're saying the list for this age gets this name added to it. So now let's see, we also need to change this because now we're going to get back a list. And so we can say print hello one of and now if we say 6, we're going to get actually oops. Oh, right, because it's now age to names. We changed the name to match what it's doing, which is a pretty correct thing to do. So, so now it can say, okay, you're either Pinky or Genoa. Remember, Pinky's not a real person. Let's see. All right, so what else could we do to make this better? Well, first of all, that output was a little crunchy. How can we make that better? One way is to use join. So instead of just printing the list like that, we can, let's actually switch back to this one, which is a little nicer. Hello, and what would we want to join with? We'd want to join with or. What is this doing, you might ask? This is going to put space, OR space, between the names. So for this one, oops, and yeah, of course I forgot to update this one here. Okay, there. Age to names. Let's see here. Did I do join right? Yeah. So now it says hello, Pinky or Genoa, and that looks pretty natural, like something a human might actually write. And if there's just one matching, then ta-da, that's a little easier. So now we can actually handle multiple people with the same age in the system. At this point, it's probably nicer to say, to just say something like, I don't know anyone turning that age. And we can put me in here. There, now I'm in there. All right, what could we do better? One last thing I want to point out that we could do better here is this part where we said had to make an empty list the first time we run into an age. We could actually import collections, and there's a really cool little tool in collections called defaultdict. So what we can actually do is just say age to names equals, oops, there, equals collections.defaultdict list. And what this does is whenever whenever you try to reference a key that doesn't exist in the dictionary yet, it just instantiates something with that key, creating a new object of the type that you put here. Well, it runs this. It issues a call to this. So it'll run list, and whatever that returns is what's going to get put as the value of the key that wasn't in there before. So now I can take out those two lines. And this is, once you sort of know what you're doing, this looks a little more obvious, like, oh, I see what's happening here. This is a dictionary full of lists, and when we instantiate a new key, like, we'll just put an empty list in. All right, and so now we can run this again. And it works like we thought. So there we go. Let's see, what changes did we make here ultimately? We took our we encoded our data as a data object rather than in the code, so that our code we could have a small amount of code that covers a multitude of possible outcomes. We use defaultdict to populate a reverse lookup table based on the data we had, and we also handled a case where we have two people of the same age and having nice output using str.join that can handle making it look nice and sort of natural, the result that we give. So there you go. This is the sort of ultimate. There you go. There's the imports up there. But other than that, this is really the code that we ended up with. Cool. Thanks to my nephew Cadence for sending me these cool little examples to start with, and for putting up with me giving feedback. I think he's doing a great job, and I'm just trying to point to some of the cool stuff ahead on the road. So there you go. Have fun coding.